Hello, welcome to this video. I'm Surush Nekui, a graduate student in material science at University of Tehran. In this video, we want to talk about how we can use Xpert HighScore software to calculate crystal size and Microstrain. But in first step, we have to talk about introduction or fundamentals about our calculation and what parameters are effective in our calculation. Um, As an example, when we look at XRD pattern of bulk and non-crystalline of cerium oxide, we can see that there is a broadening in XRD pattern of non-crystalline cerium oxide. That can be from features like internal features such as defects, grain boundaries, and defects like that. So we can say that observed peak can be from internal features of our sample. But in addition to that, it can be from instrument configuration or the parts of our XRD analysis. So the observed broadening can be from both uh, internal features of our sample and from our instrument configuration. About the crystal size, we want to distinguish between crystal and particle. So in the next slide, we want to talk about how they are different. When we look at the powder, we can see that the particle size and crystal size can be equal or different in their size. When the particles are formed of individual crystallites, we can say that particle size is equal to individual crystal size. But when there's an imperfection or the particles are formed of imperfect single crystals, we can tell that particle size is larger than single crystals. Um, so why is it important for us? Why crystal size is important? Because when we reduce size into geometric scale, there will be a loss of specific plane diffraction. So there will be no more preference for diffraction rather than bulk materials, because in bulk materials is more probability for preference or more preference in plane diffraction rather than non-metric scale samples. So the sharpness of the peaks will be reduced, so the intensity reduction can be seen in our XRD pattern. And about the peak broadening, we can tell about this parameter in next slides. But about the boundaries, as you can see, the dislocations between boundaries and defects like that can be effective in crystal size and the appearance of our XRD peaks. That we will talk about it more about in next slides. In next slide, we want to talk about strains and how load can be effective in our XRD pattern. Um, we can divide it into uniform and non-uniform strain. In uniform strain, when your specimen or sample um, is the compression or tension load is applied on your sample or specimen, there will be shift in peak position. So the peak will be shifted into right or left position. But in the non-uniform strain, there will be a mixture of peak positioning, shift in peak position, because there will be a mixture of compression and tensile stress in our specimen. So there will be no more preference for shift in peak position, and the peak will be shifted into right and left position at the same time. So the peak broadening will be seen in the XRD pattern. And about the inclusion and imperfection, we can see that when the X-ray film inclusion, or imperfection, like particles, you can see that there will be more strain than the perfect X-ray film. So the shift in peak position will be seen in the XRD pattern. So it is important how we prepare our samples or what is the synthesizing method. Like when we ball mill or mechanical milling our sample, there will be a mixture of load applied on our sample. So there will be a complex situation for our samples. So there will be a shift in peak position, addition to peak broadening in our XRD pattern. Um, about the method that we are going to talk about is Williamson Hall plot. Why we choose Williamson Hall plot, and what about the other equations, like Sher equations? Why we prefer this method rather than Sher equation? Because this plot includes both of size and instrumental parameters. This equation consists of two terms of size strain and instrumental broadening. So we can plot it into y and x-axis. As you can see, we can plot these trends and observe how y and x variables differ in different ranges or in different theta. We have beta multiplied by cosine theta in y-axis and 4 multiplied by sine theta in x-axis. So we can easily plot this trend by using Williamson Hall method, but we do it more precisely in Xpert HighScore software. We can also rearrange this equation by inputting shape factor equals to 0.9, and for the Microstrain or broadening produced by Microstrain, we can input different term. So we can plot it and see that how size and strain have a competitive role in our plot, because there's a competition between size and strain. For example, when we have a sample that ball milled for 2 hours, when we heat treat our samples, there will be a reduction in role of strain, because when we heat treat our sample, the crystallite size or the effect of the size will be more than strain. So as you can see, the B plot is a horizontal line. But about when we just ball mill our sample for 2 hours, there will be mixture of size and strain, but the strain will be more than size. So we can see that there's a linear function or linear relationship between these of two y and x variables. It depends on what treatment or what process we applied on our samples. Um, but if we want to distinguish between strain and instrumental related broadening, we have to use standard references. Why we use standard references like silicon or hexaboride lanthanum? Because there will be negligible strain or size peak broadening. So by reducing the importance of size or strain-related broadening, we can see that the, the broadening related to instruments is equal to our observed broadening. So if you want to observe the instrument-related broadening, we can use standard references like, as you can see, silicon, aluminum oxide, or hexaboride lanthanum. So, thank you for your attention and hearing my explanation. In next videos, we want to talk about shared equation and how we can use Xpert HighScore software. But in first steps, we want to talk about fundamentals more. Then we will talk about how Xpert HighScore software um, is about Xpert HighScore software application and how we can use it in order to calculate a Microstrain and crystal size of our sample. Thank you for your attention, and if you like this video and if it is satisfying for you, I appreciate to subscribe or like my videos. Um, dislike or subscribe will help me to go on and upload more videos about materials characterization and videos related to materials science.